Okay, so today we are going to complete notes number 3, which is solving two-step equations with fractions. And we're going to look at decimals today as well. So I kind of love these notes because I feel in a way like when I'm solving these equations, I'm doing a little bit of a magic trick. Okay, so I feel like they really push students to challenge themselves in terms of understanding what's happening with these fractions. But I also think they're kind of fun to do because of kind of the magic that happens when we're getting rid of the fractions and the decimals. So before we do that, I want to kind of just give a demonstration as to like why it's okay to do what we're about to do. So this is like a little side note, totally unrelated to this equation. If I had something that said x equals 2, okay? If I were to take that equation and I were to multiply it by 2 on both sides, then that's going to give me 2x equals 4. And so what I'm going to ask you is, did I change the value of x at all by basically doubling that equation? The answer would be no, right? Because I could still divide that 2 out on both sides, and it would still be x equals 2. And in fact, I could take this original equation, and I can multiply it by anything, and I'm not actually changing the value of that variable. Okay, when I go to solve, I'm still getting x equals 2. I'm just kind of getting a multiple of the same equation. And again, if you think about that balance, as long as whatever I multiply one side by, I multiply the other side by, I'm not changing the value of the variable, okay? So just one more time to go through that. If I had taken this x equals 2 and I multiplied them both by 10, okay, that would have given me 10x equals 20. Still x equals 2. Okay, so I can multiply that original equation as long as I multiply both sides by something, or similarly, I could divide both sides by something and it would still be equivalent. So that's kind of a big piece of the magic that happens here. So when I encounter a linear equation where I have a whole bunch of fractions going on, I don't want to just kind of struggle through the equation and have to deal with finding common denominators and combining fractions through addition, subtraction, multiplication, and division. I don't want to even deal with that. So what I can do is I can choose to multiply by something that will clear my fractions. And as long as I multiply everything, both sides of the equation and every term on both sides of that equation by the same amount, then I'm not actually changing the value of my variable. And what I want to multiply by is what's called the least common denominator. Okay, so I'm going to look at my denominators and decide what would their common denominator be, and then I'm going to multiply through by that LCD. Okay, so to clear my fractions, I'm going to multiply by the LCD, by the least common denominator. And again, the important piece here is that I multiply everything to keep that balance. So on our example here, and the way that I like to write this is I put the entire thing, both sides of the equation, the whole shebang in brackets. And I'm going to take this, everything here, and I'm going to multiply it by the LCD, which in this case would be 14. If I were to take 7 and 2 and get a common denominator, the least common denominator between 7 and 2 would be 14. So I'm going to multiply every single thing in this equation by 14, whether it's a fraction or not a fraction, okay? So I'm basically just distributing 14 through to every single term, every single thing that's happening in this equation. And it's 14 over 1. And so when I multiply, and I'll show some work kind of over to the side here. Let me get actually a scrap piece of paper, cover this up, okay? When I multiply 14 over 1 by negative 2/7, just to kind of show you what's happening there. Okay, when I multiply by this first term, okay, remember that I can reduce fractions before I multiply. So 14 over 7 is just 2 over 1. And then 2 times negative 2 would give me negative 4r. Okay, so this first term, when I multiply by 14, becomes negative 4r. The second term is just 2r. So 2r times 14 is just going to become 28r equals, and now I have 14 times 1/2r. Well, half of 14 is 7r. Plus, and this last one's a little bit tricky, when I take 14 and I multiply it by 17/2, again, I can reduce here. 14 divided by 2 is going to give me 7 over 1. And then 7 times 17 is going to give me 119. Okay, for my last term here. So 7 times 17, one way that I can break this down, well, 7 times 10 is 70, and 7 times 7 is 49, and I just add those together. Okay, so 7 times 17 gives me 119 for my last value here. And now look, magic, there's no fractions left, okay? So by multiplying every single term by the LCD, boom, I've eliminated my fractions. Really pretty magical, okay? If I do this and I still have fractions, then I didn't do it correctly, okay? So I should, as long as I'm choosing the LCD, it should always just wipe out the fractions in that first step. And now I just have a multi-step equation. So I'm going to combine these like terms because they're on the same side of my equal sign. So I have 24r equals 7r plus 119. And now I'm going to collect my variables to one side. So I'm going to subtract 7r, which would give me 17r equals 119. And now I'm going to divide by 17 on both sides, which 17 goes into 119 evenly and gives me r equals 7. Okay, so let's look at another example of this. So example 1, we have 2x subtract 4/5 equals 13/15. Now, I certainly could struggle through with the fractions and get a common denominator and do all of that work, but it's a heck of a lot easier to just clear my fractions. To clear these fractions, I look at the denominators and decide what would their common denominator be. Well, 5 and 15, their common denominator is 15. So I'm going to multiply everything. Okay, the trick here is everything needs to get multiplied. Fraction, not a fraction, left side of the equation, right side of the equation, every single term. So multiplying 2x by 15, it's going to make that 30x. Multiplying negative 4/5 by 15. So again, let me do a little work over to the side. Negative 4/5 times 15. This is going to reduce, become 3 over 1. And then I can multiply. That's going to give me negative 12. Equals 13/15 times 15. 15 over 15 is just 1 over 1. This just becomes 13, or in other words, these 15s are just canceling out. And now solving, I add 12, and I get 30x equals 25, and I divide by 30, and x equals 25 30ths, and we would never leave that because that can be reduced to 5/6. Okay. Let's look at another example. So here for fractions, I have 3/5, 1/10, and 5/2. If I look at those denominators, 5, 10, and 2, common denominator would be 10. So if I want to clear my fractions, then I'm going to go through the entire equation and multiply it by 10. And again, I got to make sure I have this term, that term, this single term of 1x, and this term. 3/5 x times 10, well, 3/5 times 10. So another way that in the past has helped students kind of work through how to multiply our fractions here is I kind of have two options. So I can either multiply the numerator and then divide by the denominator, or I can take this number 10 and I can divide it by the denominator and then multiply it by the numerator. But what's happening here is that number in the top, the numerator, is getting multiplied by this term, and the denominator is you're dividing by. So in my head, I could either do this. I could do 10 times 3 is 30, divided by 5 is 6. So it's going to become 6x. Or I could say 10 divided by 5 is 2 times 3 is 6. Okay, so it doesn't matter which order you're going in, but I'm taking an integer and I'm multiplying by a fraction. I'm multiplying that integer by the numerator and I'm dividing it by the denominator. Same idea here. 10 times 1 is 10, divided by 10 would give me 1 x, so just x there, equals 10 times x gives me 10x, minus 10 times 5 halves. Okay, so 10 times 5 is 50, divided by 2 is 25. Now I have my equation, so I'm going to combine like terms. 6x and negative x gives me 5x equals 10x minus 25. Now I wouldn't subtract 5x here because that's going to, what I say, zero out this side, or it's going to leave me with nothing on the left-hand side of my equation. So instead of doing that, I don't want to like eliminate a side of my equation. I'm going to subtract 10x instead, which would give me negative 5x equals negative 25. And now I want to divide by negative 5 on both sides, and I get x equals 5. Okay, so this is tricky stuff, tricky stuff. I'm going to let you try 3 and 4 on your own. So again, idea is figure out what the common denominator would be, multiply the whole equation by it. Figure out what the common denominator would be, multiply the whole equation by it. Okay, and then once you've tried them on your own, I'm going to show you my work, but I'm going to kind of do like a quick talk through my work so that if you don't get the same thing as I do, hopefully my quick talk through will help you see why that may be. Okay, so I'm just going to do a quick talk through here. The LCD between 4, 3, and 6 would be 12, and then multiplying through, I need to make sure I hit all terms. 12 times 3/4, well, 12 divided by 4 is 3, times 3 is going to give me 9x, minus a third of 12 should have given you 4x, plus 5 times 12, you don't want to miss that piece, gives me 60, equals 5. 6 times 12 is going to give me 10x. Okay, 12 divided by 6 is 2, 2 times 5 is 10. Combining like terms gives me 5x plus 60 equals 10x, and then getting my variables to one side gives me 60 equals 5x, and dividing by 5 gives me x equals 12 on number 3. On number 4, the common denominator between 3, 2, and 6 would be 6, so I'm going to multiply all of these terms by 6. 2/3 times 6, well, 6 times 2 is 12, divided by 3 would give me 4x, minus 1/2 times 6 is going to give me 3x, equals negative 1/6 times 6 is going to give me negative 1x, and then I can't forget to multiply the 6 by the negative 2, gives me negative 12. Combine like terms here gives me x equals negative x minus 12. Add x to both sides, and I get 2x equals negative 12, and divide by 2, and we get x equals negative 6. Okay, so you'll get some more work with clearing fractions on your homework. It's tricky. Practice is what's going to make it feel a little bit less tricky. but this is something definitely we'll continue working on. Along with being able to clear fractions, we want to be able to clear decimals. And this is probably going to be a little easier in terms of the process of clearing them. And when we clear decimals, we are going to be multiplying by either 10 or 100 or 1,000 or whatever we need to multiply by to clear all of our decimals. And that's kind of going with a concept that if I have a decimal, multiplying by 10 is going to move it one place to the right. Multiplying by 100 is going to move it 2 places to the right. 1,000, 3 places to the right. Okay, so we know that multiplying by multiples of 10 is just moving the decimal place over. Or if I was going the other way, okay, dividing by multiples of 10 is going to move my decimal the other way. So when I look at an equation, like on number 1, I can see that the most movement I need to make on my decimals to clear them is 2 decimal place moves that I need here and here. I always just go with the most that I need to clear. So if I want to move my decimal over 2, then I need to multiply everything by 100. So whether or not it needs 2 decimal place moves, every single piece of the equation is going to get 2 decimal place moves so that I keep it balanced, right? Everything has to be multiplied by the same amount. So if I move my decimal place over 2 or multiply by 100 on the first term, it's going to give me 483p. Plus multiplying by 100 on the next term gives me 740p equals multiplying by 100, 2,446. Okay, moving over 2 decimal places. And notice here, I just added a 0 in for that extra decimal place. So now I have some like terms. So I have 483 and 740p. And adding that together, I'm going to get, let's see, so I have 483 and I'm adding together 740, and I get 1,223p equals 2,446. And now to solve for p, I'm dividing by 1,223. I don't know if you can see it here, but 244 or 2,000, man, how many times am I going to do that? 2,446 divided by 1,223 is actually just 2. Okay, this is half of that, reduces down to 2. Let's look at another example together. So on to number 2. Again, so here I would only need to move my decimal place over 1 spot over here to clear the decimals, but here I would need to move my decimal place over 2. So we're going to multiply everything by 100 so that fractions, or so that my decimals get cleared everywhere, including this place here. Okay, so everything though needs to get multiplied by the same value, and that's going to make this 320m minus 680m, I'm just moving my decimal over 2, equals negative 2,232. Okay. Now, combining like terms, that gives me negative 360m equals negative 2,232. Then I'm going to divide by negative 360. This one won't be quite as simple to reduce. So first of all, it's a negative over a negative, so I know that's going to make it a positive. I can see that they're both even numbers, so I know that I can at least divide them by 2. I'm looking at the 36 and I'm saying, okay, well, I can divide that by 6. Can I divide the top evenly by 6 just to start reducing? And so just a quick little check over to the side, 2, 2, 3, 2 divided by 6. 6 goes into 22 3 times, gives me 18, gives me 43, goes in 7 times, gives me 12, goes in 3 times. So yeah, I can divide this by, oops, not 3 times, 3 times. I can divide this by 6 to start reducing. So that's going to become 372 over 60. I'm just kind of giving myself a starting place. I can see that these are still even, so I can reduce more. I want you to notice that I also cleaned up negative over negative is positive. So let's see, 372 dividing further. Let's see, can I divide that by 6 again? So 372 divided by 6. This would be 6 and 12. So yep, that's going to become 62 over 10, again, dividing by 6. So sometimes for me, I don't know, maybe for you, you can get right down to the first, the final reduction of this fraction. But for me, sometimes I have to work through it a little bit. So just taking this initial fraction, okay, I can divide both of these numbers by 6, reduce it. I can divide these again by 6. And now last, I still have even numbers, so I'm going to divide them by 2, which would give me 31 over 5. And that cannot be reduced anymore. Okay, so final answer, reducing that all the way, is 31/5. Don't give me the decimal answer. In fact, you won't have access to, I just used a calculator for a minute. At one point here, I can't remember where, oh, maybe over here, I added these together. I noticed I grabbed a calculator. You won't have a calculator on these assessments. So you don't want to kind of cheat your way through and write like the decimal version of this. You want to get that practice of, okay, how can I reduce it? Can I keep reducing it? Oh, I can keep reducing it. Now I'm done. I can't reduce this anymore. They don't share any common factors, okay? Let's look at one more. So again, I'd have to multiply by 100 to clear the decimals across the board, and just being really careful to multiply everything by 100. So my first term would become 100x plus 520 here, moving my decimal over 2, plus 60x, again, moving my decimal over 2, equals 584. Combining like terms, that gives me 160x plus 520 equals 584. And subtracting 520 from both sides gives me 160x equals 64. And then dividing by 160, x equals, so one thing I know is that 16 goes into both 64 and 160. So 64 divided by 16 is 4. 160 divided by 16 is 10. And then I can reduce that a little bit more down to 2/5. There's my reduced answer. So now I'm going to give you a chance to look at 4, 5, and 6, and then I will show you my work and you can check your answers. Okay, so now I just want you to check over your work. All of these we multiplied by 100 to clear the decimals. Honestly, I think on most of the homework you only have to multiply by 10 just to make the numbers a little bit easier. So just want to point out, just because we had to multiply by 100 on all of these examples doesn't mean that that's always the right answer. Sometimes I only need to move my decimal place over 1, then I multiply by 10. Sometimes I have to move it over 3 spaces, then I multiply by 1,000. So it all depends on the equation. So in our first one, I get negative 1705 over 550. It looks like I dropped my negative. And I can reduce that. You can see over here, I noticed that this ended in a 5 and this ends in a 0. So I knew they were both divisible by 5, and I did that first. And then I could divide it even further, each of those numbers by 11, and reduced it down to negative 31/10. On number 5, initially had 549 over 90. So if you got there, you're doing good. These were both divisible by 9, gave me 61 over 10. It's completely reduced there. On number 6, again, here's my initial answer is 483 over 690. So first I reduced that to 161 over 230. And then I was able to reduce it further down to 7/10. So if you were getting like even to here, that's awesome. I just really want to kind of see, and if you don't reduce it all the way, minimal points off. But what I want to see is you doing that work of trying to reduce it as far as you can. ideally all the way. But if you are getting at least to the final answer, then that's great. We know we're solving it correctly. And then the next step is work on those factors and getting our fraction reduced, our answer reduced all the way. So tomorrow you'll have, actually not tomorrow because it's Friday, so you have some homework number 13. Homework number 13, no, that can't be right. Homework number 3 that will give you a lot of practice with this fractions and decimal stuff. And so my biggest hint to you is don't cheat yourself and use a calculator. These are really, really important skills to practice, and they're difficult. So it might take you a while to work through the problems, but the practice will be super important in the future.